Very good morning, students. The next we are going to see is with electromotive force. This is a very important one. Electromotive force. We can say it as EMF. Okay. So EMF, it is a electromotive force. So what is this EMF is? Imagine that two ends of a water pipe is filled with water and are connected. So just consider a pipe and that two ends are being connected. Okay, so it has been connected like this. Although filled with water, the water will not move or circle around the tube on its own. So this is fully what it has been filled with water, okay, but the water will not move in this, okay, it will be just stable, or it will not also circle around this. Why? Because if there is no force which is being applied over here. Suppose you insert a pump in between, okay, so in between this, if you just insert a pump, okay, pump, when you're placing it between, and the pump pushes the water, then the water will start moving in the tube. So because of this pump, what happens, it push the water, and because of that push, all the water in this tube will move. Okay, so what is said here is, if anything, if it is stable and it does not produce any type of movement, and suppose if you are giving an external force to that, that particle moves. Okay, so without the external force, any particle will not move, and that type of force is called as a electromotive force. And now, moving the water can be used to produce some work. Okay, so since the water is being made to move, that can be used to produce with some work. We can insert a water wheel in between the flow and make it to rotate. And same way, in between the flow of water, we can also make any wheel to move in between and make it to rotate, such that it makes the water to move in all the directions. Okay, and this can be used. Clear? And this is a diagram. And first, if you consider the water system, so this is a water system, and first, if you consider without any pump, then the water will not move. And next is, if you are placing with the pump here, this gives a push in this, and so the water will move here. Same way, if you consider any electrical circuit, without the battery there will not be any connection. Okay, there will not be any current flow, but with the help of battery, when the battery is being placed, what happens, there is a current flow in this. Yes, clear? So pump, it more or less the same as a battery. Yes, only if the external agency is there, there is a current flow. So devices like electric cells and other electric energy acts like a pump. So electric cells, electric energy, they all act like a pump and pushing the charges to flow through the wire or the conductor. So what it does, it push the charges to flow through the wire or the conductor, whatever we are considering, it just push the charges. So the pumping action of the electrical energy source, it is made possible with the help of this electromotive force. Okay, so the pumping action, so with the help of which we are giving a force. Okay, that force is called as what? Electromotive force. Okay, and the electromotive force is represented by the letter E. Okay, so small e, and the EMF is a electrical energy, and it is the work done by the unit charge. Okay, so E, which is given by work done by the unit charge. So E is equal to W divided by Q. So the equation is E is equal to W divided by Q. In this, W is the work done. Okay, and what is the unit of this EMF? Is EMF is equal to what? W divided by Q. Now, if you write the unit for this can be written as 1 joule, and unit for this charge is 1 coulomb. So we write joules per coulomb, because J divided by C, When you take this c to the numerator, this can be written as j c power minus 1. Okay, so this is a unit for electromotive force, which is EMF. Okay, and the other unit is volt. Okay, so other unit for this EMF is what? Volt. Yes, now we have the definition of EMF. Yes, so what is the definition of EMF? Is it says that the EMF of an electric energy source is 1 volt. Okay, so E is equal to what? W divided by Q. Yes. So what is the unit for this? E is 1 volt. Okay. So when this value will be 1 volt? When we have the work done to be 1 joule and the charge to be 1 coulomb. Okay. So the EMF is 1 volt. Okay. When we get the EMF to be 1 volt, when 1 coulomb, 1 joule of work is done. So work done, if you are considering as 1 joule, and the charge, if you are considering as 1 coulomb. Okay, clear? So 1 volt, which is equal to 1 joule of work, and for the charge of 1 coulomb. Clear? So this gives the definition of this EMF of an electrical circuit. Clear with this? What is an EMF? Yes,